Welcome back to our last part for the day. We'll be looking into similarity. Let me just try and assist here. When you talk about congruency, let's look at my two hands. Exactly the same. But if I take a hand of a child of somebody with a bigger hand, they'll be the same, but the other one will be bigger and smaller. That's when we refer to similarity. They are equally the same. Congruence, everything same size, same shape. Right? Same size, same shape. Right? Different size, same shape is when you talk about similarity, but let's work at that. Let's look at this page, our rectangle. Our rectangle. Let me get a smaller one. Let me get the smaller rectangle that will fit here. There's your rectangle. Let's start. When we fold it, this one fits exactly on top of this one. Right? Let's fold that way. Again, when we fold it that way, let's mark it with a color pen here, you see, so that we can see color. We can see color here. Let me try my level best to get a straight line. Right? Then when we fold it that way, let's fold it that way. The color is exactly same shape, same size. That is our congruency. Our congruency. You know? That's right. Let's check now. Right? You can see this is congruent to that one. Huh? That's clear. This side equals to that side. This side equals to that side. This is 90, there's 90, there's 90, there's 90. Right? That is your congruency. Now, if you take, let me use straight away a scissor. Let's cut it now. We're going to cut it into 4 parts. So we're going to cut it into 4 parts. Let's start. These two congruent. We still agree. Congruent. Okay? Because we want to move to similarity now. They are all congruent. Right. Now, where are our figures now? 1, 2, 3, 90 is outside. Okay. 1, 2, 3, 4. That's one there, that one here. 1, 2, 3, 4. 1, 2, 3, 4. Yes, there's our original figure. Right. Now here's my question. We agree this is a rectangle. Right? We agree this is a rectangle. Okay, let's just give it a size. Quickly, let's give it a size. Let's say this one is 4 centimeters, 4 centimeters, 5 centimeters. Okay, let's say 6 centimeters, 6 centimeters, 6 centimeters, 6 centimeters. Right? Therefore, this would be a 4, this will be a 4. Now, let's check now. We agree this is a rectangle. right? Do they have the same size? No, this one is bigger than this one, right? Therefore, we can say they are similar. Same shape, but different size. That's the difference between generally similarity, but we'll come to the questions more and illustrate more. Let's go back to the figure that we left here and get deeper into similarity. Right. Let's look at this one. It says similar on the left. That triangle is bigger than this one. But let's see what they have in quality, in commonality. What do they have in common? You see, this angle is 83 degrees, this one is 80 degrees. This angle is 65 degrees, this one is 65 degrees. This angle is 32 degrees, this angle is 32 degrees. So similarity, same shape, different size, but angles must be equal. Angles, equiangular. All angles must be equal. Let's emphasize that one. We go to this one, it's a triangle, and a triangle is a bigger triangle and a smaller triangle. Let's look at the angles, 38, 38, 106, 106, 36, 36. Therefore, same shape, different size, equal angles. Same shape, different size, equal angles. Those are three important things. Let's look at this one. It's a four-sided figure. Let's look at the angle inside. We've got 50, we've got 50. We've got 98, we've got 98. We've got 55, we've got 55. We've got 57, we've got 57. Because mathematically, you have to prove for equal angles. Equiangular. Before you can decide they are similar, and as well as proportionality, we'll go through proportionality as well. We'll go through proportionality as well. All right, before you continue, we'll also deal with the proportionality. Let's look at the last one. It's a four-sided figure. The other one is bigger, the other is small. Let's look at the angles. 82, 82. 106, 106. 94, 94. 78, 78. And remember, with congruency as well, we have to check that the angles are equal. But same shape, same size, congruency. Same shape, different size, equal angles. That's very important. Now, when we look at something that is not similar, look, the angles inside are not equal. The angles inside are not equal. That's very important. The angles inside are equal. They might be same shape, but the angles inside are not equal. Right. Let's look at, we'll come back to the proportionality part of it. Oh, should we do it now? Let's just do it now. Let's just do it now. Let's look at the proportionality. Now, one is equal angles. All angles must be equal. Let's look at proportionality, what we mean by proportionality. Let's work at proportionality now, because those are the two important features of when figures are congruent. When figures are, similar, I meant to say. Similar. All right? Let's look at this one. We agreed one angles might be equal, equiangular. It's called equiangular, especially when you reach grade 12. That's where similarity and proportionality will also be waiting for you. Whatever you learn down here is a foundation. You started 1 plus 1 in grade 1, you still will use it in grade 12 when you say, okay, 2 to the power 1 by 2 to the power 1. It's 1 plus 1, 2, yes. So all the mathematics that you learn down there, you need it up there. Especially this one, not especially, even this one in grade 12, it's very intensive there. Now let's look at the, for example, let's look at the red angle. and look at the sides opposite the red angle. Ne? Or should we look at the blue? It doesn't matter which one. Red angle here. The red angle is opposite 10 meters. That's important. Triangle 1 and triangle 2. Right? Let's give it the names already. Let's name them so that we don't have to go back. A, B, C, and then D, E, F. D, E, F. Right. Now let's start. We start with red angle. We start with red angles. We say, okay, triangle, in triangle ABC, red angle start with A, angle A. In that one is angle F, sorry. It's angle F. All right. Angle F. We agree they are equal. Which other angles again are equal? The green one in this side is a C. The green one. What is the green one on the other triangle? It's your E. It's your E. No, my color blindness now. sorry. Colors. A is red. It's clearly it's red. Sorry, it's red. I'm trying to. Okay, this might be confusing, but let's just use one color. Red is A this side. Red in this side is F. Right? Blue in this side is C. Blue in this side is D. Green in this side is B. Green in this side is E. That order is very important. See? The side opposite a red angle is BC. The side opposite red angle is BC. Here the side opposite red angle is DE. That order is very, very, very important. Therefore, we use this sign to say they are similar. Remember congruency. Remember similarity. So that is very, very important. Because we are going to say which side are we going to choose now? Let's see. AC. Should we choose AC? Okay. AC. Let's choose side AC. AC is equals to 24. AC this side. And then obviously that side we're going to choose FD because of that order. Therefore, FD is 16. Point number 1. Then let's choose which one now. AB. AB is this one. What is AB equals to there? 21. Then obviously this side we choose FE. What is FD? 14. And let's Mathematics, your fractions are coming back again. You see now, your mathematics is relationship subject. How many 4s in 24? 6. How many 4s in 16? 4. How many 2s in 6? 3. How many 2s in 4? 2. How many 7s in 21? 7. 3. How many 7s in 14? 2. So this is important. When you divide all those sides, they must give you same ratio. In other words, that is called they are in proportionality. They are in proportionality. They are in proportionality. Fine. That's very important. Two things: proportionality, equiangular, you said it, equal angles, similarity. Just in summary, what is expected from you in terms of similarity. Similarity, same shape, different size, equal angles, or equiangular. It's the same shape, different size, equal angles. That's very, very important. Number one, when you have to put proportionality, similarity. Number two, proportionality. AB over DC should be equals to EF over GH. That proportionality. Right? 16 over 20 should be equals to 4 over 5, ultimately. Those are the two most important things. But we won't be doing too many questions on similarity. We'll do it on the next session on the 28th, just to follow up. On the 28th, just to follow up. Like I said, remember that proportionality is important. That proportionality, which side? What is important? The angle is opposite which side? That's very important. The angle opposite, the side opposite 106 is 56. The side opposite 106 is 21. The side opposite 36 is 24. The side opposite 36 is 9. So you always compare the proportionality. Let's look at this one now. In the figure shown below, PQR is similar. It's similar. They are telling you it's similar now. PQR is similar. They want the length of PR. They are looking for the length of PR. Okay? Let's look at the length of PR. They are telling you they are similar. Looking for length of PR. Now remember what the proportionality that I spoke about. That is why this order is important. Then you will be able to say, okay, the first two letters, PQ over the first two letters, JK, is equal to the second and the last, second and the last. You just follow those letters as they are there. QR over KL. And of course the first and the last, first and the last, first and the last, which is PR over JL. Is very, very important. This is very, very important. Now the question is looking for PR. Therefore, you'll use PR over JL. Now you will check, what are you given there? What size do you have? You have got JK. When you look at the two figures, you have got JK. You are also using PQ. So therefore, that's what you're given. Therefore, you're going to use PQ over JK. Because that's what you're given. That's what you're given. That's what you're given. That's what you're given. That's what you have. That's why it's important to read what is in front of you. Now, PR, do you have JL? Yes, JL is equals to 12. Are you given PQ? Yes, PQ is equals to 12. Are you given JK? Yes, JK is equals to 9. Mathematics. Make PR subject of the formula. You should make PR subject of the formula. Because you only want PR. You don't want to see that 12. You are going to multiply it with an inverse, which is 1 over 12. Sorry. 12 over 1. Let me just write it nicely. PR over 12. You multiply it with an inverse, which is 12 over 1. But remember, with equations, whatever you do on the left, you're also going to do it on the right. Therefore, you say 12 over 1. And then 12 and 12 ones. Therefore, your PR, that's your PR. All right? And then how many 3s in 9? There are 3 of them. How many 3s in 4? In 12? There are 4 of them. How many 3s in 3? 1. How many in 12? 4. Therefore, your PR will be 16 now. Your PR will be 16. So it's important to know the proportionality and the equiangular. Let's see the other question that we can do, and then next time we will start again with similarity. Let's do this question. Right. Let's see the bit shorter one. Right. Let's look at that question, the second question. Let's look at the second question, and next time we will just continue with similarity. Let's close with that question, and then we'll come back to similarity next time. Consider 2 triangles below. Now, you are expected, we are talking about this question now. You are expected to prove that they are similar. Prove that the angles are equiangular. Right? In other words, firstly here we don't have angles, then we have to prove proportionality. You have to prove proportionality there. So it's 2 ways. You are not given angles, therefore you cannot use angles. Therefore you have to look at the proportionality. Let's look at proportionality. Let's look at proportionality now. Let's look at the proportionality. The triangles below. Right? So 2 ways, you prove equal angles or you prove proportionality. Now you'll need to identify which side over which side. This side is opposite bigger angle, you'll compare with that side. That side, compare with that side. Therefore, we say, let's see. AC over DF. AC over DF. Let's see the relationship there. AC 7 centimeters. DF 14 centimeters. Oh, sorry. AC 7 centimeters. How many 7s into 7? 1. How many 7 to 14? 2. So we've got the first one. Now we'll compare the second one. AB over DE, what's the situation? AB over DE, what is the situation? AB over DE, what is the situation? AB over DE. AB over DE, yes, there you are. AB over DE. Right. AB, what is AB equals to? 4 centimeters. What is DE equals to? 8 centimeters. How many 4s in 4? 1. How many 4s in 8? 2. You see now. They give the same ratio. They give the same ratio. Right, lastly, CB, which is 5 centimeters, over FE, which is 10 centimeters. How many 5s into 5? 1. How many 5s into 10? 2. So they are similar. Therefore, you can say, all right, AC over DF, we agree, equals to half. Equals to AB over DE, we agree, equals to half. Equals to CB over FE, which is equals to half. Therefore, then you must follow that order. Therefore, triangle A, which is opposite 5. B, C, similar to what? We must follow that order now. A, opposite those sides that give you proportionality. Therefore, it will be D, and then B and E goes with E, and then C goes with F. C goes with F. And again, we can see the first 2 over the first 2. AB over DE equals to second and the last, second and the last. Equals to first and the last over first and the last. So that is important. That order is very, very important. Right. The last one now, because similarity is based on proportionality. If figures are similar, they will be equiangular. That's number 2, what it means. If they are similar, they will be equiangular. Let's end our lesson there for today. On the 28th, we'll be continuing with congruency and similarity. Now you'll be doing more questions now. Exposure on more questions. But based on those 2 topics, remember when you come, learn your properties of quadrilaterals, parallelogram, rectangle, rhombus, square, and a kite. And remember your congruency, same size, same shape, same size. That is congruency. Same shape, different size, but equal angles and proportionality. That is the difference of those 2. We'll continue again on the 28th. just to remind ourselves of properties, and then we'll be doing more questions as a way of revising. Thank you very much.